Okay, this tutorial we're going to talk about finding the area of oblique triangles. And we know that the word oblique, that basically means that it's a non-right triangle. And typically when we're talking about finding the area of a triangle, what makes it a little bit challenging is we need a base and a height, right? And the formula that we're more familiar with is 1/2 base times height. But we know for a triangle, the base and the height have to be perpendicular. So if you call this your base, then the height has to be this perpendicular line to that base. And if you don't know what that is, it makes it a little bit challenging to find the area of that triangle. So today we're going to learn two different formulas that you can use based on the information that's given to you. So the first thing is something called Heron's formula. And you can use Heron's formula if you are given three sides of the triangle. So if you are given all three sides of the triangle, you're going to use this formula. It's a bit long, so bear with me, but I'll explain what this means. So the area is equal to the square root of a really long expression, and it's going to be S times the quantity S minus A times the quantity S minus B times the quantity S minus C, all of that underneath that radical. And the A, B, and C, those are your side lengths, right? We have A, B, and C. So what is S? S is what we call the semi-perimeter. And think about what these words mean. We know the perimeter, that's the distance all the way around the shape. Semi means half, so it's half the perimeter. So you would basically be taking A plus B plus C to get the perimeter, and then you're dividing it by 2 to get the semi-perimeter. Okay, so let's jump ahead. I'm going to do this with one of the problems there on your worksheet. So let's jump down to this question here. So let's find the area of this triangle, and we were given all three sides. So that's what lets us know that we're going to use Heron's formula. That's named after a famous mathematician. It's not just a random name there. So what we need to do first is really find that semi-perimeter. So we want to take 315 plus 125 plus 280 and take that sum and divide it by 2. And in this case, your semi-perimeter is going to be 360. The nice thing about this formula is now it's really just plug and chug. So the area is the square root of the semi-perimeter, 360, times, and then we're going to do 360 minus every single one of those sides. So minus the 315, 360 minus the 125, and 360 minus 280. And then we're doing the square root of that entire product. So obviously we have to follow order of operations. So we want to do all of the subtractions first. So we have 360 times, well, 360 minus 315 is 45. 360 minus 125 is 235. And 360 minus 280 is 80. So we want to multiply all of those and then take the square root. And we multiply all of those, we're going to get a very large number. Let's see, 4, 5, 6, and then 4 zeros. So what number is that? 304,560,000 that we are square rooting. And anytime that you're not told what to round to, I would say just make sure to give at least one decimal, maybe two. So let's go ahead, round to the nearest hundredth. And in this case, you should get 17,451.65. And our label, since everything is in feet, we're in area, so it's going to be feet squared. So that would be our final answer there. So that's Heron's formula. And again, you can use that anytime you have an oblique triangle and you are given three sides. But of course, you're not always given all three sides. You might be given two sides with, let's say, the angle between them. Well, in this case, you can use a different formula. And it has to be the angle given has to be between the two sides. But it's not necessarily A and B. It could be, side A and C or side B and C. It doesn't matter, but we're just going to call these sides A and B here. And we're going to use those sides in this formula. So the area equals 1/2 times A times B times the sine of theta. Okay, so A and B, these are just your two sides. So these are your two sides, and this is the angle between them. Okay, now it actually doesn't matter what theta is. We've seen a lot of formulas where theta has to be in radians. Theta can be in radians or in degrees. You just need to make sure that based on whatever your angle is given in, your calculator mode matches that. So as long as you make sure of that, you're good to go. So this example down at the bottom of the page, take a look at that. We have two sides and the angle in between them. Okay, it does not matter, again, that this is side C and this is side A. It doesn't matter. Instead, just think of it as, okay, for this formula then, we're going to do 1/2 times our two sides, so times A times C, and then times the sine of that theta. So in this case, 1/2 times the first side, so 3, times the second side, which is 10, times the sine of our angle, which is 120 degrees. Now, the sine of 120 degrees, that's an angle that we're familiar with. 120 degrees, the y coordinate of that terminal point is √3/2. And then over here, we can say 3 times 10 is 30, and half of that is 15. So it's going to be 15 times √3/2. And if I don't tell you to keep it exact, then we'd obviously go ahead and type that in our calculators and get an approximate answer. And this ends up being about 12.99, and our label would be centimeters squared. Okay, so there's one more example. The last example I want you to leave blank for now because I know that that uses the law of cosines, and we haven't done that yet. So this is really the hardest that it can get for us. It's kind of, looking at the area of this triangle, but it's in a bigger problem. So we want the area of this shaded region right here, correct to 2 decimal places. So think about what that means. That means we need to figure out this entire area, which is a sector. Good thing we already found that formula, right? The area of a sector, we know that formula is equal to theta r squared divided by 2. But in that formula, remember, theta has to be in radians. Okay? So if we find the area of that sector, then we can also find the area of the triangle, and we could subtract the area of the triangle from the area of the sector and be left with just that shaded region. So again, let's just go back to finding the area of the sector. So in this case, what is theta? Well, I'll erase this just so you can see it better. But 120 degrees, again, we should be very familiar with 120 degrees. We know 120 degrees is equivalent to 2 pi over 3 radians. So we're going to use 2 pi over 3 in our formula. So 2 pi over 3 times r squared, well, our radius is 2, so times 2 squared or times 4, divided by 2. So 4 over 2, we can go ahead and simplify this. 4 over 2, that is 2. So 2 times 2 pi over 3 ends up being 4 pi over 3. Now I'm going to go ahead, I'm just going to keep this for right now. This is the area of the sector. I'm just going to keep it exact because we'd like to just round one time at the very end. Now let's work on finding the area of this triangle. Well, if I know that the radius is 2, then that means that we know that this side is also 2, which means we have a side, and the angle between them. So we're going to use that formula 1/2 AB sine of theta. Okay, so in this case, we're going to say 1/2 times 2, because those are my two side lengths, times the sine of, and again, it doesn't really matter. You can use 120 degrees, or you can use 2 pi over 3. I might just use 2 pi over 3 because I'm keeping everything in radians right now. But it's completely up to you. We should know the sine of 2 pi over 3 anyways without our calculators. So the sine of 2 pi over 3, we calculate that, right? We know that that's √3/2. And then times, 1/2 times 2 is 1, times 2 is 2, so it's 2 times √3/2, which means we end up just getting √3. So this is the area of the triangle. So in order to get the area of the shaded region, the area of shaded, we know that that equals the area of the sector minus the area of the triangle. So really all we have to do is 4 pi over 3, and we want to take away that √3. And at this point, you're probably going to pull out the calculator. It said that we could round to 2 decimals, and you could type it in, and you should get about 2.46. We don't have a label here, so we can just say that that is units squared. Okay? And that's it. It's pretty straightforward.